Right. Magnitude and direction. Okay. So this is the magnitude part of a vector. So the way that we find the magnitude of a vector is we take the square root of the sum of the components squared. So understand that the A and the B here would be the components. Okay. Now, when we wrote a vector, how do we normally write a vector with what two specific variables? Go back and remember that. I and J, right? All right. So the A part there would sort of be the I component. You wouldn't actually put I in there, okay? And then the B part would be the J. Remember, there's sort of two ways to write a vector. You can write it with that I and J notation, or I kind of like the other way, which this book doesn't really use, is use those parentheses that look like that, the greater than. I like that notation better because that's just the way I was taught to calculate. Now, I really don't care for that whole I and J thing. All right. Now, I got that formula. That's a really important formula. And by the way, I'm making you a study guide that basically goes over all the formulas. So it's like a study guide for the formulas. Because you're going to have a lot of formulas to remember on this test. All right. Now, so let's look at this one. So we got a vector V, and this question's asked me to find the magnitude of the vector. Okay. So it's actually a pretty simple question. All we got to do is use that formula. Now, what's our components here of the vector? -5 and 12, right? So let's look at the formula. We'll do it like this. Right. So the magnitude of V is equal to the square root of A squared plus B squared. So our A component is that -5. So I'm going to go ahead and square it here. So that's going to give me what here for the A squared? 25, right? And then the B squared, right, 12 squared would be 144. So 25 and 144 would be 169. So what's that going to give me then? 13 simplified? Yeah, 13. Okay, so the magnitude of the vector is 13. So now, if we see a vector, we should know how to find the magnitude of it. It's just a simple formula. Okay? And so that tells me, remember the magnitude tells me how long the vector is. All right, now, the other way we have to describe the vector is by the direction. Okay, and so this is where, well, hang on that part. Let's look at these real quick. These are really simple questions. And so all these are what we call vector operations. Okay, what I was thinking about was the direction of the vector. Okay, then we'll see that in just a minute, and that's where the tricks will come along. Now, basically, this looks just the way it sounds. It says we got a vector V, -4i plus 2j, and then we got a vector W that's -6i plus 5j. So this says to find 4v plus 3w. Now this is exactly the way that it looks. Okay? So how would you think we would do 4v? And by the way, what did we call 4? We had a specific name for a number like that. None of that vocabulary. A number that multiplies a vector. It's a whole number usually. It's a scalar. Okay. So we're saying 4 times vector v. So I'd say 4 times -4i plus 2j, and then plus 3w. So it's a plus 3 times -6i plus 5. Okay. Now, what do we do with a scalar like 4? We just, exactly like it looks, you multiply. Okay? So this would give me -16i plus 8j plus, it would really be what, minus, 18i plus 15j. And now we're adding basically two vectors together, and when we add two vectors, we add the A component with the B component, right? So negative 69, negative 18, now it's just like terms, right? Would be what, negative 34i. And then 8j and 15j would be 23j. Okay? I mean, really, it don't get much easier than that. These are really, really straightforward. Now, next one is going to be sort of like this, except for it's going to deal, I think, with the magnitudes. Okay? Now, so let's talk about what does this mean right here? V minus W. Is that just taking the vectors and subtracting them? What is that really subtracting? The magnitudes. The magnitude of V minus the magnitude of W. Okay? So what we need to do to figure this out is find the magnitudes of the vectors. Okay? So let's start off with V. Let's find the magnitude of V. Now, remember, go back. How do we find the magnitude? The square root of sum of the square of the components. Okay? All right? So help me out. This will be the square root of what? Yeah, 16 plus 25 would be 41. And I think square root of 41 is simplest form. Okay? So there's the magnitude of V. Now, what about the magnitude W? Let's say, yeah, square root of 4 plus 9 would be the square root of 13. Okay? Now, let's answer the question. So what's the magnitude of V minus the magnitude of W? Square root of 41 minus the square root of 13. That's it. Can I actually subtract that? 41 minus 13 is 28. You need it. They have to be alike, right? To subtract radicals, they have to have like radicals. All right. Now, let's get back to more of what we were talking about. All right. Here's another term, the unit vector. Yet another formula. Okay. Now, you kind of copy that, but basically, what we can do is, let's just say we have a random vector. A unit vector for another vector is a vector that's in the same direction, but if we say unit vector, that means what's going to be the magnitude of that vector? 1. Unit as in 1. So let's say that we got like a vector that's like, you know, you measured the magnitude is 16, the unit vector would only be 1. And so what we have to do is make the components come out to give me a magnitude of 1. Right. So notice the unit vector, they say U, is equal to the vector, V for vector, divided by, what does this mean right here? The magnitude. So you have to take the vector and divide it by the magnitude. Okay, that's basically how you find the unit vector. You want me to kind of write that out for you? Right. So the unit vector it's the vector divided by the magnitude. Okay, so let's look at finding a unit vector. Okay, I got all that? You know, okay, I'll need to go down and let you copy the list. Alright, it says find the unit vector having the same direction as V. So we want a vector that goes the same direction as V does, but a unit vector is only going to have a magnitude of 1. Okay? We've got to make that happen. Now, go back to our formula and kind of copy that down. So the unit vector equal to the vector divided by the magnitude of the vector. Okay. So before I start throwing stuff in that formula, what's maybe something I need to look at? The magnitude. Okay. So the magnitude of my vector. Right. Remember that was that formula that we started off with, the square root of a squared plus b squared. So in this case, it's almost the same one we just did earlier. We do what, 144 plus 25. And then that would be the same one that we did earlier, I think, isn't it? Right. Yeah, 13. Okay. So now, we're going to take the vector and divide it by 13. Okay. So we're going to have negative 12i minus 5j over 13. Now, let's write that. See, a vector, should be sort of two separate things. So we're going to separate the fraction. It's going to end up looking like this. Negative 12 over 13i minus 5 over 13j. Okay, you'll kind of see how that formula works there? The vector divided by the magnitude of the vector. All right. And so if you think about what happens, all right, now that's my answer there. But what if I were to find the magnitude of this vector? Yeah, this is the answer. Okay. Yeah, what was it? Yeah, this is my answer right here. But if I wanted to check it, okay. All right, I could check it by finding the magnitude of that vector. What should the magnitude of the vector be? 1. Because it's a unit vector. So the idea is that this vector and this vector are different, but they go in the same direction. All right? So this vector had a magnitude of 13. This vector would only have a magnitude of 1. Okay? So to kind of show you visually what it would look like, that might be my 13 vector, and then this would be my unit vector. Same direction, but different magnitudes. Okay? Now, let's look at finally more of the trig form. So the trig brings in the direction. Okay? So we've been really focusing on the magnitude. Now let's switch over to the direction. So your textbook, your software doesn't refer to it in the trig form. That's just my kind of take on it. So it's sort of the trig form of a vector. So notice you take the magnitude of the vector times the cosine of alpha I plus the sine of alpha j. Okay? And alpha is your angle that's coming off of the x-axis. Okay, so now this is where actually the trig kind of starts. All right. And so by giving an angle and going off the x-axis, now you bring in direction. Okay. All right. That's one of another formula that I've got on your study guide. Now let's look at this. Write the vector v in the form ai plus bj, given its magnitude of v and the angle alpha that it makes with a positive x-axis. Okay? Now, let me write down that formula. You might have to help me write it down real quick. Let's see, what was it? The magnitude of v times, look what, the cosine of alpha I plus the sine of alpha j. Now, let's talk about how that relates to what we said, like in other trig stuff. The first component we think of, to me, I see x. And then I see y because I'm thinking of an ordered pair. Now, what did we said about x and y? But the x coordinate would be the cosine, and the y coordinate would be the sine. Okay, that's one way that you can kind of help remember that. Now, in this case, our magnitude is 11. Okay, so they don't give you a vector and make you find the magnitude. They go ahead and give you the magnitude. Okay, so an 11 times. Now, y'all see what alpha is going to be? It says it there. What, 60 degrees? 11 times the cosine of 60 degrees I plus the sine of 60 degrees J. Now, these are values that we know, right? Okay. So what's the cosine of 60 degrees? Half. Okay. Right. So we get 11 times 1/2 I plus. Now, what's the sine of 60 degrees? The square root of 3 over 2. Square root of 3 over 2 J. Okay, now what do you think we're going to do with this thing? Yeah, multiply it. Okay, so give me 11 over 2I plus 11 square root of 3 over 2J. Okay, and so now what I've done here is I've brought in the direction. So the direction came in from the angle. Okay, so now we have magnitude and direction together. Now, all right. Now here's a really big physics lesson here. All right, force. So physics people, I'm gonna get you to kind of help me with a little bit because it's been a long time since I've had physics. All right. So this is a vector F representing force can be expressed with this formula. Okay. Now that's basically what I just called the trig form of the formula, right? Same formula, except for we're specifically using F as force. Vector F as the force on an object. So the force is like, you know, I have this cart. If I take this cart and push it, I have to apply force to it, right? And so that's a vector acting on this cart. So think about it, if I'm pushing this way, what the amount of feet I'm pushing it is the magnitude, and then the angle that I'm pushing it is the direction. Okay, so magnitude and direction. And that's what a force does. So a force acts with magnitude and direction. Now think about this. All right, usually the force that you talk about the most in physics is gravity, right? So gravity is a force, and so it pushes down. Now, how do we quantify physics, people? Gravity, what, 9.8 meters per second squared? Okay, that would be the magnitude. Now the direction is pushing down, and if I think about that on the coordinate plane, down is 270 degrees. Does that make sense? When you draw the x and y axis, when I go straight down from the origin, it's 270 degrees. So you got, again, magnitude and direction. Now, let's look at an example here where we're going to find the force. This is actually, so, okay. It's kind of blurry there. I'll kind of read it off if you want to copy it. All right. So it says the child pulls a wagon with a force of 25 pounds. All right. So there's your force. So 25 pounds, that's the force that you're exerting the pull. That's my magnitude. The handle of the wagon makes a 45-degree angle with the ground. Express the force vector F in terms of I and J. So what they basically want me to do is take this application and write it as a vector. Now, go back to our formula. Got magnitude, my force, times, and we put it the cosine of alpha I plus the sine of alpha j. Okay. Now, the way we're going to think about this is sort of on the coordinate plane with this. So think about it. It's got a wagon. There's the handle, right? So say the handle's making a what? 45 degree angle. That's an awesome wagon. Handle's making a 45 degree angle with the ground, and it's being pulled with a force of 25 pounds. So this is what a sort of like this vector looks like. It's 45 degrees. And then the magnitude here is 25 pounds. Now, how can we write that, the vector for that? So all we have to do is really fill in the formula. I'm making it really harder than it's. I mean, you don't even have to really read the problem. You could read the two numbers and fill it in and do it. All right. So what are we going to put right there? Okay, 25 times the cosine of 45 degrees times I plus the sine of 45 degrees j. Alright. Now, what's the cosine of 45 and the sine of 45? It's actually the same thing. Alright, square root of 2 over 2. Square root of 2 over 2i plus square root of 2 over 2 j. Now all I got to do is multiply by the 25. Then I'm going to get 25 square root of 2 over 2i plus 25 square root of 2 over 2 j. Alright, now this next one is going to be kind of long and drawn out. Right? But we're going to take the same idea, except for this time we're going to look at two forces. Okay? This was just one force. Now let's look at two forces afterwards. Okay. Now, this brings in that the what force actually is. It's just like a pound. What is it, Jonathan? How do you get a Newton? Is it like feet pounds or something like that? What now? Oh, it's the force that like gravity pushes down. Okay, and so that represents like newtons. That's what a Newton is. Okay. I always thought a Newton was fruit cake. Like big Newtons. You can eat those in bed. That was the old commercial. Because they weren't cookies, they were fig Newtons. I mean, you can't eat cookies in bed, but you can eat fig Newtons in bed because they're not cookies. That was an old commercial. Y'all probably don't remember. Probably weren't even born. All right. Now look at this. You got two forces of magnitude 60 and 70 act on an object at angles of 30 degrees and negative 45 degrees with the positive x-axis as shown in the figure. Now I'll show you the picture in a minute. So that's the nice thing about it is they draw the picture for you. Okay. Now, it says find the direction and magnitude of the resultant force. Now, so basically what they're asking you to do is to find force 1 plus force 2. So really, it's just like the last problem. We're going to find a force vector, except for we're going to find two of them, and we're going to put the two vectors together. Add the two vectors together, and we're done with it. Okay? And we'll show you the picture next. Look at our picture. And they do a really good job of doing the picture for you. Okay? You know, do I need to go back for this? Yeah. not a cookie. It's cookie cake. I'm going to find that on YouTube and show you. I think it's Tuesday. Alright, now let's do this. Alright, y'all see how they've drawn the two forces? You got force 1 is going at what, a positive 30 degrees. And so notice we're talking about angles that are in standard positions. Right. So you got 30 degrees and it has a force of 60 newtons. And then force 2 with negative 45 degrees and had a force of 70 newtons. Okay? So we want the resultant force, which is basically taking the two forces, the two vectors for the forces, and adding them together. Okay? So let's work on the two vectors. All right, let's start with F1. Okay? So can we find our vectors here for F1? All right, equals, what if it go back. Yeah, go back to that. That's 60. The magnitude of the force was, the first force was 60. Okay. And then times what? The cosine of alpha I plus the cosine of alpha j. So in this case, it would be the cosine of 30 degrees I plus the sine of 30 degrees j. Okay. Now, let's see what this is going to give me, and let's take some shortcuts here. What is the cosine of 30 degrees there? Square root of 3 over 2. Okay. So what would 60 times square root of 3 over 2 give me? 30 square root of 3. Okay. 30 square root of 3 I plus, now what's the sine of 30 degrees? Half. Okay. So 60 times a half would be 30. Right. So there's that point. So that's the vector. This is that vector right there. Okay, now let's find F2. All right. So F2 is going to be this vector. So F2, now y'all help me write the vector for this one. 60, look at it again. It was 70, there you go. Right, times the cosine of negative 45 degrees I plus the sine negative 45 degrees j. Now, let's try to imagine here what's the cosine of negative 45 degrees? Square root of 2 over 2. Right. So it's going to be 70 times. Is it negative? No, it's not. It's positive. $70 times square root of 2 over 2i plus, now, what's the sine of negative 45 degrees? Negative square root of 2 over 2. So this is actually going to say minus square root of 2 over 2j. Okay, now let's multiply that out. So F2 is going to be 70 times square root of 2 over 2 will be 35 square root of 2. So 35 square root of 2I minus 35 square root of 2J. Okay. Now, go back to what the problem kind of asked you. So that's my vectors for F1 and F2. It says find the direction and the magnitude of the resultant force. So what is that? I mean, they're just telling you right next to it. What is the resultant force when I take the two vectors and add them together? Okay. So let's just take the two vectors. Let's add them together. Okay. So we got the first vector was 30 square root of 3I plus 30J. Now, we're going to add that to the second vector. 35 square root of 2I minus 35 square root of 2J. And now let's get the result. Okay? So what we have to do is add the components, right? Add the I components into the J components. Now, the thing is, can we actually add that together? No. So the way that we write it is we want to write it all as something times I. So what? We do 30 square root of 3 plus 35 square root of 2 times I. Does that make sense? Okay. Now, plus, see if you can tell me how would we write the J component. Sorry. Do I need parentheses? Yeah. Right, yeah. Okay. Parentheses. All right, now, you said what? 30 minus 35 square root of 2, close parentheses, times J. It remains. Okay. So that's the vector that's the resultant of those two forces acting on something. Okay. So imagine it's kind of like if there's like a block or something that's like really heavy, it's trying to be moved. Right? They're exerting force to like push it or something, to pull it. What happened to the order there? But wait, hold on, let's go. I must have rearranged. Yeah, did I delete it? There it is. It disappeared. Back. Right. Now, I believe there's two more problems. And these two last problems, they're not fun. Okay? So what I'm going to do for those, I'm going to video it. Because I don't want to mess you up and get up here because I don't know them as good as I should. Okay? The thing about it is by video, I can always pause the video and think about it and then do it. All right? Where I don't have to know it as well. So I'm going to video the last two problems for you. Okay? So the last two problems they're sort of similar to this one that we just did. All right? They're a little bit tougher. What they involve, let me think about it in just a minute. I can actually show you.